Assalamualaikum warahmatullahi wabarakatuh and hi. For today, we're going to continue on the structural steel design for beam. Right, so for today, we're going to learn on the example 1. A simple supported beam shown in the figure below carries that an imposed load of 7 kilonewton per meter. This is a dead load, and 5 kilonewton per meter respectively. This one is imposed load, and another imposed load which is 20 kilonewton. That one will be a point load. This two is imposed load. Assuming the beam is fully restrained, select the suitable UB section in grade 43 steel to satisfy bending and shear consideration. Therefore, this question asks you to suggest one section that can satisfy this loading. What we need to do first, we need to calculate the load because we need to find what is the shear force and bending moment due to the loading that being transferred to the beam, right? So for the ultimate load, we're going to use the formula that we always use, which is 1.4 GK plus 1.6 QK, and calculate according to the type of load, which is, this is UDL, and over here, this is point load. You have one dead load and one imposed load for UDL, therefore 1.4 here referring to the UDL, which is dead load. Okay, so 7 kilonewton per meter, that is the value. This one, that load, GK. And another one is 5 kilonewton per meter. This is UDL also, uniformly distributed load. And it is imposed load. This one. Right, so we're going to times with 10 meter because this is UDL. Okay, because of UDL, as you know, the kilonewton per meter, that is unit. So 1 meter, it is how many kilonewton lah? For example, 5 kilonewton for 1 meter. For point load, it is already in kilonewton. So if you want to add both together, because we need to calculate the total load here, means that this one you have to times with the length lah, which is in meter. Therefore, meter akan pangkah dan you akan dapat in kilonewton juga. Then you can add together with the point load punya value. That is the reason, So because yang sebelum ni, if any example in our previous chapters, kita tak ada lagi darab the length of the beam masa kita kira the ultimate load. Okay, because of there's no use of that, kita tak ada point load to add together. Then here, when I add it together, right, so I get this 210 kilonewton. What we need to do next, we need to find FV. Right, so what is FV? So FV is the value of maximum shear force. Because that is the value yang kita kena dapatkan to compare with the capacity of the section itself. Whether that section boleh carry the force yang being transmitted. Therefore, kita akan kena kira berapa FV. So, in order to do so, normally kalau kita nak dapatkan shear force, we have to draw the shear force and bending moment diagram. So, when you have UDL and point load together, combine, L over 2, meaning the in midsection of the beam. So you akan dapat something like this for shear force. Okay, and the bending moment diagram, you akan dapat something like this. So if kita tak draw pun the shear force diagram, basically we can agak that the maximum shear force adalah at the support. Okay, sebab itu yang paling maksimum kita boleh agak. So that's why kita tak perlu pun nak draw shear force and bending moment diagram. Okay, sebab 105 ni obviously itulah value maximum. And because of beam ni symmetry. Okay, so kalau total load dia, which is W, is 210 kilonewton, therefore semua load yang turun ke bawah, okay, mesti boleh disupport. So dia akan react So the reaction going to be the same value lah. If the total load going down will be 210 kilonewton, the total reaction at the support going to be similar with the total load. Akan jadi 200 kilonewton. Therefore, kita boleh just bahagi je dua, meaning one reaction di sini RA akan sama dengan RB which is you bagi je dua dan you dapat 105 kilonewton. Okay, so that's going to be the maximum value. Sebab daripada value ni, even if we draw the shear force diagram, it will look like this, and the maximum going to be at this point 105 kilonewton. Okay, so itu adalah the maximum shear force. Okay, next we need to find the maximum bending moment. So in order to do so, M here equal to WL over 4. So WL over 4 ni referring to point load punya formula to calculate the maximum bending moment, right? And WL over 8, yang you biasa tengok, this one adalah untuk UDL. Since we have both, so kita boleh just tambahkan sahaja. But there is a caveat here that WL over 4 ni, you boleh pakai this formula if the point load is at the midpoint, mid center of the beam. Memang betul-betul kat tengah. Baru boleh pakai WL over 4. Then masukkan je formula for the point load, which is we get the value of 32 here. Okay, so ini adalah value point load tadi. Masukkan saja, right? And then times with the length of the beam, which is 10 meter, divided with 4. Plus with, okay, this one, all of these adalah UDL. For UDL, okay, here, the formula as we know, it is WL square over 8. So W here, usually if in our previous example dalam chapter sebelum ni kan, okay, so our W is in kilonewton per meter. And then kalau kita darabkan dengan length, so dia jadi meter kuasa 2 lah, sebab kita kuasa 2 kan WL square. Right, so nanti kita akan dapat kilonewton meter. Okay, in this case here, if you ambil 17.8 like I did here, so you kuasa 2 kan lah di sini But kalau you dah kira terus, okay, maksudnya you dapat 178 kilonewton. Okay, so kalau dapat 178 kilonewton, dah darab 10 meter dekat masa you kira loading. For UDL, then you jangan kuasa 2 kan, you darab saja dengan 10 meter. Okay, so jadi WL over 8. Actually, the value akan jadi sama sahaja. Okay, next we going to find the suitable section for the loading that we calculated earlier. Okay, first of all, since we don't have the value of T, okay, because we know that in order to get the value of PY, which is the section steel strength, okay, kita tak tahu value thickness T ni, T besar. We don't know the value, therefore we don't know the value of PY sebab kita tak ada section lagi, right? Okay, tak apa. So kita first, we going to assume first, the value of PY is 275, meaning that mungkin kita akan pilih section yang T dia less than 16. Okay, tapi in order to get the section, we need to find the value of Sx, which is this one adalah plastic modulus. Plastic modulus as according to the moment value daripada loading tadi, which is 302.5 yang kita dah kira dari awal. Okay, so 302.5 darab dengan 10 kuasa 6 because of kita nak convert to Newton millimeter. Okay, and divide with the assumed value of PY. You get 1,100,000 millimeter cube. And since we're going to refer to the table to find the suitable section, we need to convert the value of this value in millimeter cube to centimeter cube. Okay, so as you know, 1 cm is equal to 10 mm. Therefore, if this is cube and millimeter akan jadi cube, okay, then it becomes 10 kuasa 3 millimeter cube. Bahagilah dengan 1000. So, you dapat 1100 centimeter cube. Okay, after that, we're going to find the suitable section. Okay, which means that we need to find the section yang SX dia, the plastic modulus arah X, bigger than this value because this is the minimum value. Look at this table, okay. So, table yang ni mula-mula sekali ni, dia punya section dia besar-besar. Kalau tengok serial number dia besar, okay, kalau tengok plastic modulus dia pun, di sini besar-besar. So, kita tak akan ambil lah value yang besar-besar sebab value our plastic modulus is only 1100 cm cube. Nampak? That's why kita convert the to centimeter cube. Okay, so kita akan ambil the other table, which is this table shows that the serial size dia lebih kecil and the value for plastic modulus dia arah XX lebih kecil. So, our SX is 1100 centimeter cube. Okay, what we can do is kita akan cari SX value yang lebih besar sikit daripada the value yang kita kira. So, one of it perhaps I can choose this one. Ini section dia 356.171.67. Or I can choose this one. 1190. Or perhaps I can also choose this one. Actually, you just need to find one section only, okay? As long as it's bigger than the SX yang kita kira from the moment, okay? Tapi this in this example, I show you 3 sections lah, okay? So kita boleh differentiate on each section, and it's up to you which section that you're going to choose. So we have 3 of this, and that 3 is 457 times 152 times 60 kg per m per meter UB. Okay, tadi satu, ini satu. We have 406 times 178 times 760 kilogram per meter UB. And then the other one is 356 times 171 times 67 kilogram per meter UB. Okay. So, ini yang ni lah. 1, 2 dan 3. Ini 2, 3. Okay. So, itu cara kita tulis. Okay. Sebab ini section yang kita pilih. Then, here dekat sini, so saya tulis 3 section yang saya pilih tadi. Okay. So, I can choose one only lah because we don't need to suggest sampai 3 actually. And it always depends on what exactly the requirements for your design. For example, section 1 has the least depth of 356, meaning that if you need more headroom, you nakkan seating yang lebih tinggi, okay, perhaps you can choose section number 1. Okay, however, section number 1 is heavier compared to the other 2 sections. Walaupun 406.178 ni tinggi lagi, okay, however, dia lebih ringan. Okay, means that 60 here referring to the mass per meter, meaning that 60 kilogram untuk 1 meter maksud dia kat sini. And this one untuk 1 meter dia adalah 67 kilogram. Okay, so section 2 dan section 3 lebih ringan. Section 1 is much heavier. However, dia lebih pendek lah, least depth. So it depends on what kind of design yang you nak. Okay, for this example, I'm going to choose section 2 here, which is this one. Alright, so anything after this, we're going to calculate according to this section. Okay, so kita akan ambil all the properties of this section only. Okay, so this is the section. Right, so kita nak check dulu since kita anything after this kita akan refer to this section only. Okay, so kita nak check lah whether our section ni adalah plastik ataupun compact atau semi compact ataupun slender. Right, we need to find first the value of T sebab kita nak make sure that our assumption earlier about the PY PY kita dah assume 275. Okay, T dia must be less than 16. If not, sebenarnya our assumption tu salah. Okay, so kita tak boleh. Kita kena make sure lah T untuk section yang kita pilih tu less than 16, meaning PY dia betul lah 275 as per our assumption. So kita akan refer to the table. Okay, which is this one kita ambil section yang ni 406178 yang ni So kita akan highlight dulu what is actually the value of T. So T besar dia is 12.8 for that particular section. So 12.8 we're going to refer here, okay. So 12.8 it is less than 16 mm. Means that our assumption of 275 is correct lah. Tak ada masalah. So the steel strength is actually 275. So we're going to calculate the value of constant which is 275 divided with PY square root kan dia. So masukkan the value of PY because assumption kita betul tadi. So kalau you square root kan pun tetap dapat 1 square root 1 lah. Okay. And why kita nak kira constant? Sebab kita kena refer to this table nak make sure that section kita plastik ke, compact ke, semi compact ke, which one First kita akan compare dulu the value of B over T. Okay. Untuk flange. Right. And D over T untuk web. And ini limitation dia which is for plastic is 9 constant and for flange. And for web it is 80 constant. Okay, D over T dia. Right, so kita akan compare dengan this one dulu. We need to get the value of B over T and D over T of the section. Okay, so kita akan refer to this table again. Get the value of B over T which is 6.95 here. And D over T is 46.2. Okay, so that is the value for the section. Okay, so kita akan tengok di sini. Okay, so 6.95 and 46.2. Okay, and comparekan dengan first one. Okay, kalau dia kelas 1 here, plastik, kita akan compare dengan tu dulu. Okay, sebab value dia makin naik kan. So, kita compare yang first kali. So, betul lah. Sebab 9 constant, 9 darab 1 tetap 9. 80 darab constant, 80 darab 1, 80 lah. Okay. Therefore, value B over T is less than 9. Okay. And D over T is less than 80. Meaning that both web and flange adalah plastik. 406178, 60 kilogram per meter UB section adalah plastik. So kita tahu section kita plastik. So anything yang kita akan kira after this, kita akan pakai formula untuk plastik. Okay, but first kita nak dapatkan dulu berapa shear capacity. Okay, tapi in order to do so, kita kena check on the shear buckling first. D over T is equal to 46.2. Sebab kita dah tengok dah kat belakang ni. Right, this one is 46.2. Okay. So, less than 70 constant. Constant di sini masih satu lagi. Okay, so 70 times 1. Okay, which means that shear buckling need not to be considered. This is according to clause 4.2.3. Mana saya dapat this one? Semua dari British Standard. Okay, because it mentions that ratio D over T exceed 70 constant for roll section and 62 constant for welded section. The web should be checked for shear buckling in accordance to clause 4.4.5. However, in our case here, okay, since case kita pakai roll section, kita bukan pakai welded section. Bila roll section, kita akan compare dengan 70 constant. Bila 70 constant, we know that it is less, therefore you don't need to check for shear buckling. After that, baru kita boleh dapatkan the shear capacity. Okay, using the formula of PV, which is the shear capacity, equal to 0.6 PYA. Formula ni semua, as I mentioned dalam the theoretical part of this chapter, I get from this table. Okay, so this table is from BS, 0.6 PYA. And A here referring to, kita pakai roll I section, alright? Therefore, it is TD, So, T darab D. Therefore, bila you tengok dalam the formula here, okay, A, area ini adalah TD, dia replace lah. Right? So, masukkan je value 0.6 times PY, which is 275, the steel strength. Darab dengan T. Okay, T kita tak tahu and capital D pun tak tahu. Ini semua mesti value daripada properties of the section itself. Therefore, kita akan check here. Dekat our section di sini. Okay, so value of small t here is 7.8 and the value of capital D is 406.4. 7.8 and 406.4. You darabkan je everything, you get 523.036. Sorry, 523.036.8 Newton. Okay, convert itu kilonewton sebab kita nak compare kan dengan our FV value, which is the shear force. Okay, maximum shear force yang kita kira masa awal sebelum ni. Yang kita dah kira in our previous calculation, which is here. Right, 105 di sini. If you look at this clause, it says that provided that the shear force FV does not exceed 60% of shear capacity PV. Maksudnya FV tak lebih daripada capacity 60% capacity PV. Meaning 0.6 PV lah. Okay. Jadi di sini saya darabkan dengan 0.6. Means that FV mesti tak lebih daripada 0.6 PV. So 0.6 darab 523.037 kN adalah 313.822 kN. And even kita dah pakai 60% capacity sekalipun, the value of FV is less than 0.6 PV. Therefore, we can conclude that it is low shear load, meaning that takkan terjadilah any shear failure. We're going to calculate for bending moment. So shear tak ada masalah. Bending moment juga kita kena check. Right. We're going to use this formula, moment capacity of section. Okay. Kita akan tengok because of our section di kat sini, kita dah check the section classification tadi, it is plastic. So when it's plastic, we're going to use MC equal to PYS. S here referring to the plastic modulus of section. MC adalah moment capacity. Moment capacity equal to PYS. Equal to the steel strength darab dengan the plastic modulus of the section. PY adalah 275, kita tahu. Okay, so S dekat sini, kita kena tengoklah what is actually the value of our plastic modulus. So plastic modulus ni, one maybe you boleh refer to here. Kat sini saya dah tulis sebab tadi kita dapatkan section, kita tulis terus SX berapa value dia. Sebab SX ni mesti lebih besar daripada value yang kita kira dekat sini kan. Okay, jadi dia lagi besar, so itu kita tulis section itu. Right, so 1190, okay, kat sini pun saya dah tulis. Or perhaps you can also select from the table ataupun you refer balik dekat table pun tak ada masalah. Which is inilah 1190 cm cube. 1190 itu adalah dalam centimeter cube. We must convert it into millimeter cube lah. Since ini dalam millimeter, so ini pun mesti darab dengan millimeter. Okay, so saya convertkan dan I get some values yang besar macam ni. Okay, and then kita convert into kilonewton meter, bahagi 1000 dan bahagi 1000 sebab millimeter tukar to meter, bagi 1000, Newton tukar to kilonewton, another divide with another 1000. This is the shear capacity, meaning that sebanyak inilah the beam boleh carry the moment 327.25 kilonewton meter. Okay, however, okay, for class 1 plastic or class 2 compact, okay, sebab kita punya section adalah plastik, kita mesti make sure that the MC, which is PYS, okay, is less or equal to 1.2 PYZ. Z here referring to the elastic modulus of the section. Okay, so kita nak kena dapatkanlah value 1.2 PYZ, kena check, make sure that MC ni less than this value. Right. Okay, here 1.2 PYZ I dah tulis, so 1.2/275. Okay, kita tak tahu berapa value of Z, which is the elastic modulus arah X. Okay, we need to refer to the section again, get the value of elastic modulus. So elastic modulus arah X here is 1060 centimeter cube. Right. So jadi di sini betul lah dia adalah 1060 centimeter cube convert into millimeter cube. Therefore kena darab dengan 1000. Okay, so kita dapat 349,800,000 Newton mm tukar to kilonewton meter. And we're going to compare the value of the moment capacity. It must be less than 1.2 PYZ, which means that kita dapat memang less, so meaning that okay lah, tak ada masalah. After that, kita nak kena comparekan MC dengan moment daripada loading. Okay. Moment dari loading kita dah ada, which is 302.5 kilonewton meter. However, this moment from the loading, it's not include the self weight moment. Okay, sebab beam pun ada self weight moment, it can contribute to moment juga. Saya kira lah the self weight moment using the formula of WL square over 8. Since kita tahu self weight for beam, it is UDL, uniformly distributed load. Okay, sebab sepanjang beam tu punya panjang, itulah dia punya load. Therefore, W here, okay, apa yang ini yang saya buat dalam kurungan ni semua adalah W. So, sebab kita tahu untuk kira W means that kita kena darabkan dengan 1.4 sebab dia adalah dead load. Sebab dead load, kalau kita nak kira the design load untuk any loading, dead load kita kena darab dengan factor of safety di sini 1.4. So 1.4 darab dengan the mass, sebab kita dah tahu it is 60 kg. Mana kita dapat value tu actually daripada our section kita sendiri. 60 at the back here, okay, 406, 178, 60 adalah 60 kg per meter. Maksudnya 1 meter 60 kg. It is written in our section dekat belakang sekali tu. Okay, so 60 kg ni adalah untuk 1 meter. 60 kg ni dia bukan Newton. Dia bukan weight, dia adalah mass. So kita kena darabkan dengan gravity acceleration, which is 10 meter per second power of 2. Bila kita darabkan dengan ini, means that kita nak tukar daripada kilogram pergi ke Newton. Kita bahagikan pula dengan 1000 sebab kita nak tukar Newton ke kilonewton. Right, so dalam ni, dalam our W here, okay, kita dah dapat unit dia adalah kilonewton per meter sebab sebenarnya 60 kg ni dia adalah per meter lah kan, sebab kita punya mass yang kita tengok daripada section tadi tu adalah 60 kg per meter. Okay, so dia dalam kilonewton per meter. After that, itu adalah value W. Dan kita kena darab dengan dia punya length because WL square over 8. So L square ini adalah 10 meter because of the length of the beam adalah 10 meter. dan bahagilah dengan 8. 0.5 kilonewton meter. That is the self weight. Okay, moment due to self weight. After that, kita akan dapatkan the total moment. Okay, how to get that? So this is moment due to the loading, right? Daripada imposed loading yang kena dekat beam. And this 10.5 adalah MSW, moment due to self weight. Campurkan dan this is the total moment which is MT, right? So value MT ni yang baru kita comparekan dengan value of MC. So MT must be less than MC means that barulah we can say that the beam can carry the moment daripada loading means that MC mesti lagi besar lah sebab capacity beam mesti lebih besar daripada moment yang transferred to the beam, right? Bila MT is less than MC means that the proposed section is suitable. Inilah example number 1. Therefore, we can use this the section yang kita propose. That's all for example number 1. Thank you.